Very good morning, friends. We were dealing with the reactions induced by light energy, that is, photochemistry. Today's subject of discussion is one of the photochemical reactions. We have dealt about photoaddition reactions, and today we are going to deal about photosubstitution reaction. In simple terms, it's a substitution which is performed in the presence of light or induced in the presence of light. In photoaddition reaction, addition takes place in the presence of light energy. Here, substitution takes place in the presence of light energy. Chlorination of methane using chlorine in the presence of UV light is an example of photosubstitution reaction. Here, the methane reacts with chlorine in the presence of UV light to give methyl chloride and hydrogen. The chlorine absorbs the light energy, it gets excited, and homolytic cleavage of the chlorine bond occurs and it gives rise to two chlorine radical. This is the starting point, initiation for the reaction to occur. Thus, it is named as chain initiation. The chlorine radicals, which are formed by the homolytic cleavage of chlorine in the presence of UV light, are unstable because they have one less electron than required. To regain its stability, it combines with methane, one of the hydrogen, along with its electron, one electron, it combines with this chlorine radical. It gives rise to HCl. As one electron is taken away by the hydrogen, the methane has got converted into methyl radical. In simple terms, the chlorine radical reacts with methane to give methyl radical and HCl. The methyl radical is unstable, which again reacts with chlorine molecule to give rise to methyl chloride and chlorine radical. The chlorine radical which is formed reacts with methane to give methyl radical, and the methyl radical which is formed reacts with chlorine molecule to give a chlorine radical. And the process continues until and unless all the chlorine or all the methane gets completed. It propagates the reaction. That's why it is called as chain propagation. When all the methane gets completed, then what happens? The chain gets terminated. That's why it is named as chain termination. The two chlorine radicals combine together to give rise to chlorine and the reaction gets terminated. When all the methane gets exhausted, the chlorine radical they combine again together to give chlorine molecule and there the reaction stops. Alkanes are the most rugged species. They do not react at all. The only reaction alkanes that can undergo is the photosubstitution reaction. This photosubstitution reaction has been utilized for the production of benzyl chloride. This is the industrial application of this photosubstitution reaction. 1 lakh tons of benzyl chloride has been prepared annually in the gaseous phase of photochemical reaction of toluene with chlorine. The light is absorbed by the chlorine molecule, which induces homolysis to give rise to the free radicals. Chlorine absorbs UV light and gives rise to chlorine radical, and the chlorine radical which is formed reacts with toluene. This is aryl alkane. In this, where in the alkane it reacted with methane and gave rise to methyl radical. Here it reacts with the methyl group of the toluene and it gives rise to benzyl radical and HCl. The benzyl radical which is formed again react with chlorine radical, or it reacts with chlorine molecule to give rise to benzyl chloride and chlorine radical, and the process continues and in all the toluene gets completed. This is the industrial application of this photo substitution reaction. Benzyl chloride is a synthetic intermediate which has been used as the starting material for preparation of n number of organic compounds of medicinal value. In the next presentation, let us deal with other type of photochemical reactions. Till then, have a nice day. Thank you.